So this is the 2023 Higher Level Maths Leaving Cert Paper 2, question 8. An online game involves trying to guess a 5-letter word in as few attempts as possible. For this game, each player is given a score S, where S is real, based on how many attempts it takes to guess the word. In Ireland, players' scores are approximately normally distributed with a mean of 3.87. So mu is equal to 3.87. Standard deviation is 0.36. A player is selected at random from the players in Ireland. Find the probability that the player has a score of less than 3.5. So we want the probability that x is less than 3.5. So you've got to convert that to a z-score. So that's going to be the probability that z is less than. So you've got to take 3.5 minus 3.87 over the standard deviation, which is 0.36. In other words, our z value is x minus mu over sigma. So when you work this out, you get the probability that z is less than, I think it's a negative number here, so it's going to be minus 1.027. So if you look at your normal curve here, your standard normal curve, it's going to look something like this. 0 is here. We have a z-score, a standard deviation below the mean of minus 1.027. So we're looking for this area here, the probability of appearing in this part of the curve here. Now our tables won't allow us to look up negative numbers, only positive numbers. So we're going to have to look at 1.027. We're going to have to look at the probability of appearing in this part of the table here, because these two areas are the same, the graph is symmetrical. Now again, if we look up 1.027, it'll give us the probability of being in this part of the graph down here. So we've got to do 1 minus that value to find this area up here, and hence this value here. So let's do that. So this is going to be equal to 1 minus the probability that z is less than plus 1.027. Now that gives us, when you look up 1.0, you can't actually look up 3 digits in the tables we have. So I'm going to round this to 1.03. So when you look up 1.03 in the tables, you get 0.8485. And then when you subtract these two, you get 0.1515. And that's it for part A. Let's have a look at part B. A random sample of 64 Galway players has a mean score of 3.74. So this is a sample, so it's going to be X bar this time, and it's 3.74. Based on this, a local newspaper claims that the Galway players have a different mean score to players in Ireland. Use this information about this sample to construct a 95% confidence interval for the mean of all Galway players based on the standard deviation of 0.36 in your calculations. Okay, so we have a mean of 3.74. We have a sample size then of 64, and we have a standard deviation of 0.36. So we want a confidence interval for the mean. So that's going to be, the mean is going to be somewhere between the x bar, which is 3.74 minus something, and 3.74 plus something. So it's going to be 1.96 times sigma over root n. Our standard deviation is 0.36, and our n is 64. So here it's going to be the same thing again, 1.96 times 0.36 over the square root of 64. When you work that out, you get, let's see, 3.6518, and you get 3.8284. Okay, so that's that part of the question. Let's have a look at the next one. Carry out an hypothesis test at a 5% level of significance to test the newspaper's claim that Galway players have a different mean score to players in Ireland. State your null hypothesis, the alternative hypothesis, conclusion, and reason. Give a reason for your conclusion. Okay, so the null hypothesis, which is H0, so it's going to be H0, is that the mean is 3.87. And the alternative hypothesis H1, that's going to be that the mean is not 3.87. So the conclusion here based on our confidence interval is that the Galway players are below the mean here of 3.87. So 3.87 is not within this confidence interval. So the Galway players have a different mean score to players in Ireland. So the conclusion is we reject the null hypothesis. And the reason is 3.87 is outside the confidence interval. Now actually for the conclusion here I might just say a little bit more. We reject the null hypothesis, so Galway players have a different mean score to other players if you like, in Ireland. Now one thing you could do here as well, they don't really ask for it, they only give you these 4 headings, so presumably this is all they want. You could work out the test statistic here, Z, which is going to be the x bar minus mu over sigma over root n. So the x bar was 3.74 and mu is 3.87 divided by sigma, which is 0.36, and the square root of 64 here. When you do that you get minus 2.89. So if you look at again the standard normal curve here, you've got minus 1.96, you've got 1.96 here. So this is the critical region up here and down here. And they are well below minus 1.96. So they are in the critical region. So therefore you're going to be rejecting the null hypothesis. Now, you weren't really asked for this. I'm not sure if they're going to require it. I don't think so. But that's how you would do that part anyway. Okay, so let's move on to the next question. A national newspaper conducts a survey on a random sample of N teenagers in Ireland. 35% of the sample said they played the online word game. So 35% said they played an online word game. Now that's going to be what's called p hat. The sample proportion is 0.35. Based on this 95% confidence interval for the percentage P of all teenagers in Ireland who play the game every day was calculated as accurately as possible. Correct to 1 decimal place the interval was, so we ended up here with an interval of, for the proportion, of 0.265 up to 0.435. Now use this to work out a value for N, the number of teenagers surveyed. So if you have a look at this, you can look at either end. You can look at this side or this side here. I'm going to take this one here. How was this actually calculated? So if you take the 0.435, that was calculated by taking the p hat, which was 0.35, and adding on 1.96 times the standard error, which in this case is p hat times 1 minus p hat over n. So our p hat is 0.35, 1 minus 0.35 divided by n. So we just got to solve this for n. So let's start doing that then. So the first thing we're going to do is just bring this over here. So you've got 0.435, you've got to subtract 0.35. That gives 0.085, 0.085. Is equal to 1.96 and so on. So 0.35 times 0.65 over n. Next thing I'm going to do is just divide by 1.96. So you got 0.085 divided by 1.96. That gives us 17 over 392. Now, and again, that's equal to 0.35 times 0.65 over n. Next thing I'm going to do is just square both sides here. So I'm going to square that. That gives me 289 over 153664 is equal to, let me just multiply that out, 0.35 times 0.65. That is 0.2275 over n. Next thing I can do here is just cross multiply and divide to get n on its own. So that's just going to be, I'm going to multiply these two and then divide by this here. So you end up, in fact, with an n of 120.96. Now, what will we do with this? I presume we're going to have to round this up. Let me just see, use this to work out the value of n, the number of teenagers surveyed. Okay, so let's round it up. So I'm going to say n is 121. That's my answer there. Okay, next part, D then. A player wins the game if they guess the word with 6 guesses or less. The organizers of the game record the following statistics for players in Europe. 80% of players win the game each day. 90% of the players who win the game will play it again the following day. 25% of players who do not win will play it again the following day. Some of this information is shown in the tree diagram below, based on 360,000 people who played the game on the 1st of June. The squares represent proportions. The rectangles labeled play, win and lose represent the number of people who play, win or lose the game respectively. For example, 0.8 of the 360,000 people who played the game on the 1st of June won the game. Assume that for people who play the game on a number of days, winning the game on one day is independent of winning on another day. Okay. Complete the tree diagram by writing the proportion associated with each branch of the tree diagram into the appropriate square and writing the number of people who play, win or lose the game into the appropriate rectangle. Now I've already done all of this and these are the numbers that I've got. 80%, what they say up here is 80% of players win the game on each day. So to win here, you got 80%, so losing is 0.2. Multiply 0.2 by this, multiply by 0.8 by this, you get these two numbers here. Of those people who win, 90% will play again. Of those who lose, 25% will play again. So you multiply these two to get these two numbers here. Again, if you play, you have 80% chance of winning, 20% chance of losing, 80% and 20% down here. Multiply these numbers, you get these numbers down along here. Again, if you win, 90% will play again. If you lose, 25% will play again. If you win, 90% will play. Lose, 25% will play. So multiply these numbers out and these are the final numbers here. So I think those are okay. Let's have a look at part 2. One person is picked at random from those who played the game on all 3 days. 1st, 2nd and 3rd of June. Find the probability that this person lost on the 1st of June or the 2nd of June or both. We haven't gone any further on day 3 here. We just have as far as who actually played. We don't know who won or lost. So we're only interested really in people who won or lost on 1st and the 2nd of June. So we have to find the probability that this person lost on the 1st of June or the 2nd of June or both. So really that's going to be, if I write it out here, actually come down here. So what we want is the probability that the person lost on the 1st or the 2nd or both. Now really that's going to be 1 minus the probability that the person will win on both days. So let's do that. A person winning on both days, you're going to look at coming up along here and then playing again and winning again. So it's going to be this number of people here. These 3 here involve players who've lost at least once. This player lost here and then won here. These players here won but lost here. These players here, these 900, lost here and lost on day 1 as well. So these people here won on both days. So that's 186624. So this is going to be equal to 1 minus 1, what was it again? 186624. 186624. Now, one person is picked at random from those who played the game on all 3 days. So in other words, what we get when we add up all these 4 numbers here. So if you add those 4 numbers, you're going to get 213444. And that's really it. This is our answer here. So when you work that out, you get 745 over 5929. Now it doesn't say we have to do anything with that, so I'm just going to leave it like that. Really, that's the answer. And that's the last part of this question.